Hello there! Today we've got something important for you, namely the Lorentz force. Just now you'll see what it can do and how it works to start with. Let's take a laid-back look at it. The Lorentz force belongs to electromagnetism. So it has to do with electricity and also with magnets. It was discovered by this brain here, the Dutch physicist Hendrik Lorentz. But what does the Lorentz force actually do? The Lorentz force is the force that acts on moving charges in a magnetic field. And what exactly does that mean? Let's take a look at a horseshoe magnet. It has two poles, a north pole and a south pole. And between these two poles, we have a magnetic field. It is indicated with arrows like this. They always run from the north to the south pole. If we now chase a couple of electrons through there, we would actually expect them to run right through the magnetic field. No way! This is where the Lorentz force comes into play. It acts on the electrons and shifts them in a certain direction. And we can also predict exactly in which direction the electrons will be displaced. For that, we use the left-hand rule. We point our thumbs in the direction that the electrons are flowing. Note that the electrons move from minus to plus. Next, we extend our index fingers. It's important that it is at a 90-degree angle to the thumb. It points in the direction that our magnetic field lines are running. Lastly, we add the middle finger. It must also be at 90 degrees to the index finger. It points in the direction that the Lorentz force acts. In other words, the direction in which our electrons are displaced. It's very simple, but really important. But what do we do if we're dealing with protons rather than electrons? No problem. For that, we simply use the right hand. The thumbs point in the direction that the protons are moving. The index finger shows the direction of the magnetic field, again from north to south pole. And lastly, we add the middle finger. It indicates the direction of the Lorentz force. So, we see that when we're dealing with electrons, we use the left hand. If, however, we're dealing with protons, we use the right hand. It's quite simple to remember. The second letter of electron is L, as in left, and the second letter of proton is R, as in right. This way, you always know right away which hand to use. Let's try that immediately with an example. Let's assume that these are electrons. They almost move right into the screen. So our thumbs are pointing in the direction of the screen. Just imagine that the arrow is pointing from you in the direction of the screen. The magnetic field runs from top to bottom. That's why the index finger is pointing downwards. And in which direction does that Lorentz force act? Just try it for yourselves. And what do you think? Correct, it points right. So the electrons are displaced to the right. It really isn't that hard. Okay, so now we know what the Lorentz force is and in which direction it acts. But it is a force, and one can usually calculate forces in physics. Does that apply in this case as well? Of course. We simply use the formula F equals Q times V times B. Q stands for the charge. V is the velocity of the particle. And B is the magnetic flux density. Quite logical actually. If, for example, the magnetic field is stronger, the particle is displaced further. The same applies to the velocity and the charge. So here's another crisp summary, guys. The Lorentz force is the force that acts on moving charges in a magnetic field and thereby displaces them. And we can find out in which direction the particles are displaced by using the left-hand rule or the right-hand rule. left for electrons and right for protons. Really simple. Awesome! If you're doing the subject of induction at school right now, be sure to have a look at our video, Induction through Surface Change. Till later!